And time to have a look at things happening in the world of science, and we do that with John O'Connor from the University of Newcastle Sciences. Professor John, thank you so much as always for popping in and saying hello. Today we're having a look at fuels and a way to sort of get a bit of a product that we want to throw away, but we're going to use that again. So take us through this concept, John, that you got today.
Thanks, Mark. This is a development by RMIT research group, and it's an add-on or an enhancement of something that already happens. We already convert cooking oil and some wastes into biodiesel, etc. But it's not a very energy efficient process, and it's a very sensitive one. In fact, a lot of energy goes into cleaning up the feedstock before it goes in, and so at present it's got to be no more than 2% contaminants. But this new process can actually take a broader range of sources and can have up to 50% contaminants. Now, the way it works is that they've developed a new catalyst. What's a catalyst? Well, a catalyst is something that promotes a reaction to occur without being part of the product. So it's still there at the end. In fact, there are catalysts in the mufflers of cars. It converts some of the fairly noxious gases into far less noxious gases. It still sits in there. It's usually fairly expensive pieces of metal, atoms in there, the metals, but it's easily contaminated. And that's why they had to take lead out of petrol, because that would actually contaminate this precious metal catalyst. But so this is a catalyst which will help the process, and of course, if this is going to happen at a surface, you want as much surface as possible. Now, where can you get a really large amount of surface area? And that's inside a sponge.
That's a very good point, isn't it?
It is.
So I guess this is where the ceramic sponge comes into play.
That's right. So this is a ceramic which has little holes in it, and it's on the surface in those little holes that the reaction takes place. So the chemicals, the fuel stuff, feedstock goes in with a bit of heat, not too much because this is now much more efficient. A little bit of heat, it will convert into various molecules which can be reconstructed into becoming the biodiesel. Now, where they've made a real advance here is that that sort of process has occurred for years. I mean, many people have got that sort of process. They've actually been able to functionalize this sponge so it's got holes of different sizes, and different reactions take place in different holes. So it goes through a sequence of reactions, all in the one catalyst. Whereas in other cases in the past, they go through one catalyst, produce something, they'll go into other, and so on.
So is this really a case of reducing a lot of separate reactions or separate phases into one, into less?
Exactly. It's a nice sequence of reactions, all in the one catalyst. Out the other side comes the biodiesel, and they believe that they can actually use this now to apply in other areas. So they're talking about producing. They think they can tailor make it to make jet fuel. Now, can you imagine biojet fuel? That would save an enormous amount of greenhouse gases going in the atmosphere, and they think they can make it from agricultural and forest waste and old rubber tyres and even algae. So this holds a lot of promise for us to be able to recycle materials. In other words, have a net zero carbon emission in this process, whereby we take these byproducts from somewhere else, put it through this process, and produce a biodiesel.
And I guess at the end of the day, we're talking about products that have had their initial use or single use primarily. They're there anyway. They're just going to waste, to landfill, to other sources. If there's a way to drive them back in and be reused in this way, that's a good thing.
Well, it's not only that, it's one step up. Can you imagine how you would get rid of used cooking oil if you didn't reuse it somehow? And you can't pour it down the sink. You can't put it out in landfill. You don't want to put it out in landfill. So certainly it's got to be processed somehow, and it's great that they've developed a very energy efficient way of using it and other sources of similar material, other fats and so forth, highly contaminated. So in the past, if they're highly contaminated, that'd be an issue, but even highly contaminated sources, and produce into a very valuable product.
With the help of the humble old sponge.
And certainly the RMIT group have got high hopes in what this new discovery will make, and it could actually change the whole catalysis industry. And catalysts worldwide are worth something like $34 billion. So it's a big market out there.
It's not chump change, is it?
If you can, it's not just for biodiesel, and there are an enormous range of reactions that utilise catalysts. And in fact, most of our manufactured products at some stage encounter catalysts somewhere along the line. So they've got a huge potential market here. They've just got to do the hard work now, which is to go from something that works to something that's a commercial enterprise.
All right, well, they'll wait and wonder on the next steps. Professor John O'Connor from the University of Newcastle Department of Sciences, thank you as always for your time. Appreciate it.
Thank you, Mark.
2NURFM, a broadcast service of the University of Newcastle.